Welcome to another academy. Today's topic is mechanics. Mechanics is broadly classified into two types. One is statics, another one is dynamics. In statics, we are dealing with the objects which are at rest. In dynamics, we are dealing with moving objects, isn't it? So, today we are going to discuss about forces acting at a point. That is, in statics, we are discussing about forces acting at a point. So let's see some definitions and theorems in the beginning, and then we will do some problems based on the theorems. Okay, the first definition is resultant and components. See, suppose if in a body, okay, rigid body, I have several forces F1, F2, F3 and so on, etc. So several forces are acting on a rigid body. Okay, suppose instead of all these forces, I can find a single force capital R which can give the effect of all these forces. Okay, that is replacing a number of forces into a single force uh, with the same effect. Then this R is called the resultant and this F1, F2 are called the components. Okay, right. Then next one is parallelogram law of forces. See, suppose if at a point A, I have two forces P and another one is Q, right, making an alpha with each other. Okay, P and Q are two forces acting at a point A with an angle alpha. Then the resultant of the two forces P and Q is given by the diagonal of the parallelogram. Okay, the diagonal of the parallelogram. So how do you draw this parallelogram? See, this AB, you know, this is representing the force P in magnitude and direction, and this AD is representing the force Q in magnitude and direction. Suppose if this is possible to represent the forces P and Q by the sides of a parallelogram taken in order, then the resultant of these two forces is given by the diagonal of the parallelogram. Okay, and this diagonal is giving the resultant, and this makes an angle phi with the first force P. Okay, so what is the conclusion of the parallelogram law of forces? If you have two forces like this, then the resultant is along the diagonal of the parallelogram. Okay, so using this parallelogram of forces, we have derived the resultant, the value of the resultant R as, that is the magnitude of the resultant R is equal to square root of P square plus 2P P square plus Q square plus 2PQ cos alpha, where this alpha is the angle between the forces P and Q. And tan phi equal to, what is this phi? Phi is the angle made by the resultant with the first force P. Okay, tan phi equal to Q sin alpha by P plus Q cos alpha. Okay, we will discuss some special cases here. Suppose if P and Q are acting at right angles, then what happens here? Cos 90, no, cos 90 is what? 0. So simply R will become root of P square plus Q square, and this tan phi will become Q sin 90, no, sin 90 is what? 1. So Q by, here this Q cos alpha again becomes 0, so Q by P. So these results are derived from the general result. So this is the first case when the forces are acting at 90 degree. Next one, suppose if both my forces are equal in magnitude, okay, the magnitude of P and Q are equal. In that case, what happened to this result? This will be P square plus P square. So 2P square plus here it will be again 2P square cos alpha. So by simplifying that, I will get R equal to 2P cos alpha by 2 and phi equal to, here this will be what? P sin alpha by P plus P cos alpha. Here it will be what? So this P in the numerator and denominator will get cancelled. I will be getting simply what? Alpha by 2. Okay, right. Next one. Suppose if two forces are acting, then when will they have the maximum resultant and minimum resultant? Okay, so when will they have the maximum resultant? By looking at the resultant R, you can conclude that the resultant is maximum when cos alpha is maximum. When will you have maximum value for cos alpha? When alpha equal to 0. When alpha equal to 0, cos alpha takes the value 1. 1 is the maximum value for cos alpha, no? So the maximum resultant is obtained when alpha equal to 0. That means what? The angle between the forces is 0. That means P and Q act along the same straight line in the same direction. So in that case, the maximum value of R is given by P plus Q. Okay, right. And what about the minimum value? The minimum value depends on the minimum value of cos alpha. When will you have minimum value of cos alpha? For alpha equal to 180 degree. So for alpha equal to 180, cos alpha equal to what? Minus 1, right? So when will you have 180 degree? When this P and Q are acting in the same line but in the opposite directions. Okay, so when the two forces are acting in the same line along the same direction, you will have the maximum value and it is equal to P plus Q. When they act in the same line along opposite direction, you will get the minimum value for the resultant, and that is given by P difference Q. This is difference, okay, whichever is greater that you have to put in the front. So either it may be P minus Q or Q minus P. Okay, so these are the results regarding the resultant of two forces acting at a point. Next one is triangle of forces. Again, this one will give you the resultant of three forces acting at a point. Suppose at a point I have three forces P, Q, R acting, and suppose if I can represent these forces, three forces, in magnitude and direction by the sides of a triangle taken in order. That means this P, let me name this triangle as ABC. Okay, suppose this AB is taken so that the magnitude of P is represented by the length of AB, and magnitude of Q is represented by length of BC, and magnitude of R is denoted by the length of CA. Okay, this triangle represents the three forces both in magnitude and direction. Okay, then in that case the resultant of all the three forces is equal to 0. So this is called triangle of forces. Okay, right. Then if two forces, from the triangle of forces we have one result. That is, what is that? Instead of three forces, suppose if I have two forces only. Okay, one is represented along AB, another one is represented along BC. Okay, this is my P and this is my Q. Okay, then the resultant of these two forces is equal to AC. Okay, here I can't apply parallelogram law because I'm having like this, no. Okay, so here in this one, what should I do? We can apply parallelogram law by extending this AB this side so that P can be considered here. But using triangle of forces, what can you conclude? That is P plus Q is equal to, that is AB plus BC is equal to AC will give you the resultant. That is, here R is taken in the reverse direction because P plus Q plus R equal to 0, no. So if you take it in the reverse direction, that will give you the resultant of these two forces, right? Okay, then next one is perpendicular triangle of forces. So what is the difference between triangle of forces and perpendicular triangle of forces? Here also we have three forces acting at a point, right? And here the forces, direction of the forces are such that each force is perpendicular to the side of a triangle. That is, direction of P is perpendicular to BC and direction of Q is perpendicular to AC and direction of R is perpendicular to AB. In this case also the forces will also be in equilibrium. So what is triangle of forces? There the triangle represent the forces both in magnitude and direction. Okay, but here in perpendicular triangle of forces the sides are proportional to the forces and the direction of the forces are perpendicular to the corresponding sides. That means BC, the magnitude of P is proportional to BC and direction of P is perpendicular to BC. Similarly, Q, magnitude of Q is proportional to AC and it is perpendicular to, the direction is perpendicular to AC. And R, magnitude of R is proportional to AB and direction of R is perpendicular to AB. Okay, so in this case also the resultant is equal to 0. Right, this can be generalized. Not only this 90 degree, suppose if my forces make equal angle to the corresponding sides, then also the forces will be in equilibrium. It need not be always 90 degree, it may be any other degree, but all the angles should be what? Constant. In that case also, what do you say? The forces will be in equilibrium. Okay, next one is converse of triangular forces. Suppose if three forces acting at a point are in equilibrium, okay, then if you draw a triangle, right, so that their sides are parallel to the direction of the forces, then they will the triangle will represent the forces in magnitude also, right? So what are my assumptions? The three forces acting at a point are equilibrium. I am drawing one triangle and the direction of the triangle, that is the sides of the triangle, are parallel to the direction of the forces. So what is my conclusion? The triangle will represent them in magnitude also. Okay, so this is converse of triangle of forces. This is true. Okay, next one is polygon of forces. Polygon of forces is nothing but an extension of triangle of forces. In triangular forces, what do you say? If three forces acting at a point be represented in magnitude and direction by the sides of a triangle, then they will be in equilibrium. The same thing here, if any number of forces acting at a point be represented in magnitude and direction by the sides of a polygon taken in order, then also the forces will be in equilibrium. Okay, but the converse of the polygon of forces is not true, because in triangle we have similarity of triangles, no, but in polygon the similarity is not true, therefore converse of polygon of forces is not true. Okay, the next one is Lamis theorem. This Lamis theorem is also about three forces acting at a point. Suppose three forces acting at a point are in equilibrium, then each force is proportional to sine of the angle between the other two forces. That is, if PQR are acting at a point, keeping it in equilibrium, then P is proportional to sine of angle between Q and R, Q is proportional to sine of angle between R and P, and R is proportional to sine of angle between P and Q. So this is called Lamis theorem. Next one is extended form of parallelogram law of forces. In parallelogram law of forces, what did I say? That is, the forces, two forces acting at a point are represented in magnitude and direction by sides of the parallelogram, isn't it? But here I am taking two forces. One is lambda into OA, another one is mu into OB. See, this OA is this side and OB is this side. So I am not having the force equal to the magnitude of OA. Okay, proportional to this one, that is lambda times OA. My force is lambda times OA and this force is mu times OB. Then the resultant of these two forces is given by lambda OA plus mu OB equal to lambda plus mu into OC, where the C is such that lambda times AC, the C divides this line in the ratio lambda and mu. Okay, right? So this is an extended form of parallelogram of forces. We can put a particular case for this. If you put lambda equal to mu equal to 1, then what happens to this result? OA plus OB equal to 2 into OC, where C divides this AB in the ratio 1:1. That means what? C is the midpoint of AB. Okay, so this result we very often use for solving problems. Okay, so these are the results that I am going to discuss in this video. I am going to discuss 13 problems. Each one is of different type. So by doing these 13 problems, you can be thorough with all the concepts that I have discussed so far. The first problem, the greatest and least magnitudes of the resultant of two forces are R and S. So let me write the statements one by one. So what are R and S? The greatest and least magnitude of two forces. So let me take P and Q be the two forces. So what is the greatest and least means what? Maximum of the resultant and minimum of the resultant. So what is the maximum value of P and Q? That is, maximum resultant of P and Q can have P plus Q. And the minimum of the resultant of P and Q will be what? P difference Q. So R equal to P plus Q and S equal to P minus Q. So this is the given thing. When the forces act at an angle 2 phi, okay, what is the angle between the two forces? 2 phi. Okay, so this is the first case, this is the second case. Third case, what they have given, when they are acting at the angle 2 phi, find the magnitude of their resultant in terms of R and S. So with the same force P and Q, here we are discussing three different cases. One is when they are acting at the same angle, then only we get maximum resultant, no? So this is when they act at angle 0. When they act at angle 180 degree, at that time we get minimum resultant, no? So P minus Q. Third case, what they have given, they are acting at angle 2 phi. In this case, what is the resultant? That is what we have to find. So let R1 be the new resultant when P and Q act at an angle 2 phi. Then R1 equal to, what is the formula? Square root of P square plus Q square plus 2PQ into cos of the angle between the forces. So here the angle between the forces is what? 2 phi. So 2 phi. Okay. Now we want to write the result in terms of R and S they have given, no? So now see, what is R? P plus Q. So what will be R square? P plus Q the whole square, no? So P square plus Q square plus 2PQ. And what about S? S square equal to P minus Q the whole square. So equal to P square plus Q square minus 2PQ. Now if you add these two results, what will you get? 2 times P square plus Q square. So instead of this P square plus Q square, what can you write? R square plus S square by 2. And then when you subtract these two results, when you add these two results, you will be getting P square plus Q square. When you subtract these two results, you will be getting what? PQ. So instead of this 2pq, what can you write? R square minus s square by 2, right? So what will you have? R1 equal to square root of 1 by 2, you take it outside, r square into, right, r square into r square into 1 plus cos 2 phi. That is, I am taking, see, this is the result we have finally there, no? You take r square outside, so what will you have? 1 plus cos 2 phi. And if you take s square outside, you will be having 1 minus cos 2 phi. So r square into 1 plus cos 2 phi plus s square into 1 minus cos 2 phi. Okay, but what is 1 plus cos 2 phi? 2 cos square phi. So here you substitute 2 cos square phi, and 1 minus cos 2 phi equal to 2 sin square phi. Okay, then you simplify. So what will you get? This 2 and 2 will cancel, no? Everything is inside the square root. So what I get? The resultant equal to square root of r square cos square phi plus s square sin square phi. Right? That's all. Next problem. If the resultant of two forces P and Q is at right angles to P, then find the angle between P and Q. So angle between the resultant and what? The first force is given to be 90 degree. What we have to find? Angle between the forces P and Q. So usually what we take, alpha is the angle between the forces P and Q, and we usually take phi as the angle between the resultant and first force, isn't it? So what is the formula? Tan phi equal to Q sin phi by P plus Q cos alpha. Okay, right? But what phi is given to be 90 degree, no? So tan 90 equal to, but what is tan 90? Infinity. That is 1 by 0 equal to Q sin alpha by P plus Q cos alpha. Our aim is to find alpha. Now cross multiply. What will you get? P plus Q cos alpha equal to 0, or cos alpha equal to minus P by Q. Okay, therefore alpha equal to cos inverse of minus P by Q. So this is the angle between the given two forces. Next problem. Two equal forces act on a particle. Find the angle between them when the square of the resultant is equal to 3 times their product. So the forces are equal. So one force is P, another force is also equal to P. We have to find the angle between them. Right? What is the angle between them? Usually we take it as alpha. So what is the condition given here? The resultant, square of the resultant, that is r square is equal to 3 times their product. What is the product? 3 into P into P. So what is the given statement? R square equal to 3P square. First let me write what the value of r square. R square equal to P square plus Q square. Here the forces are equal, no? So P square plus 2P into cos alpha. This is equal to 3P square. That is 3 times their product. So here 2P square plus 2P square cos alpha equal to 3P square. So throughout you cancel P square. So 2 into 1 plus cos alpha equal to 3. But 1 plus cos alpha is nothing but 2 cos square alpha by 2. Therefore cos square alpha by 2 equal to 3 by 4. Or alpha by 2 is simply what? Cos inverse of root 3 by 2. Root 3 by 2 when will you get? For 30 degree, isn't it? That is pi by 6. So alpha by 2 is pi by 6, or simply alpha equal to pi by 3. So the angle between the forces is pi by 3. Okay, then next problem. If the resultant of 3P and 5P is equal to 7P, these are the two forces and the resultant is 7P. Find the angle between the forces and angle between the resultant and the first force. So let us take alpha is the angle between the forces and phi is the angle between the resultant and the first force. Then what is the result we have to use? R square equal to P square plus Q square plus 2PQ cos alpha, and tan phi equal to Q sin alpha by P plus Q cos alpha. Here R is 7P, P is 3P and Q is 5P. So substitute the value. 7P the whole square equal to 3P the whole square plus 5P the whole square plus 2 into 3P into 5P into cos alpha. So 49. Throughout you cancel P square. 49 equal to 9 plus 25 plus 30 cos alpha, or simply 30 cos alpha equal to 15, or cos alpha equal to 1 by 2. That is alpha equal to pi by 3. Now let us come to this result. Tan phi. What is this phi? Angle between the resultant and the first force equal to Q sin alpha by P plus Q cos alpha. Substitute the values of P, Q, cos alpha. So 5P sin alpha by 3P plus 5P cos alpha. So equal to 5 into, here I find out the value of alpha as pi by 3, no? Substitute the value. 5 sin pi by 3 plus, what is cos alpha? 1 by 2. 1 by 2. So 5 root 3 by 2 by 11 by 2, it's equal to what? 5 root 3 by 11. So this is the angle between the forces, and this is the angle between the resultant and the first force. Okay, next problem. Two forces of magnitude k cos alpha and k cos A and k cos B act along CA and CB of a triangle ABC. So we want to find the result. So we have a triangle ABC, CA and CB. So two forces I am having. One is K times cos A, another one is what? K times cos B. What we have to find? The resultant of these two forces. So let us make use of parallelogram law of forces. So R square equal to what? P square plus Q square plus 2PQ cos alpha. So substitute P equal to K cos A and Q equal to K cos B. So K square cos square A plus K square cos square B plus 2 into, what is this? K square cos A cos B into cos of angle between them. See, this is my alpha. Usually we take no. This is equal to what? In this triangle, this is angle C, no? So I am writing it as simply what? Cos C. Okay. Now write. So take K square common outside. So cos square A plus cos square B plus 2 cos A cos B cos C. Okay. Now in any triangle, we have a result cos square A plus cos square B plus cos square C equal to 1 minus 2 cos A cos B cos C. This result is true for any triangle. So instead of this 2 cos A cos B cos C, I am going to substitute 1 minus cos square A cos square B minus cos square C. So after substituting this cos square A cos square B get cancelled, I am simply having 1 minus cos square C. But 1 minus cos square C is what? Sin square C. So R square equal to K square sin square C, or simply R equal to K sin C. So this is the resultant of the two forces. Next problem, the resultant of two forces P and Q acting at an angle theta is given by, so two forces when they act at angle theta is this. When they act at an angle 90 minus theta, the resultant is this. We want to prove tan theta equal to. So two forces with different angles, the resultant are given at two different angles. Let R1 be the resultant when they act at angle theta, and R2 be the resultant when they act at angle 90 minus theta. Let's write the formula for R1 and R2. So R1 square equal to what? P square plus Q square plus 2PQ cos theta, and that resultant is equal to what? 2m plus 1. I have written R1 square here. So it will be 2m plus 1 the whole square into P square plus Q square. Similarly, write the value for R2. So R2 square equal to P square plus Q square plus 2PQ cos of 90 minus theta equal to 2m minus 1 the whole square into P square plus Q square. Right? Okay. So now let's rewrite. So here what we have, P square plus Q square is there, no? You take this P square plus Q square to this side. So simply what you have, 2PQ cos theta is equal to 2m plus 1 the whole square P square plus Q square minus this P square plus Q square. And similarly here also, 2PQ, what is cos 90 minus theta? Sin theta. 2PQ sin theta equal to 2m minus 1 the whole square into P square plus Q square minus of this P square plus Q square. Okay, now in this term, we can take P square plus Q square outside. So it will be 2m plus 1 the whole square minus 1. Here also we can take P square plus Q square outside. So it will be 2m minus 1 the whole square minus 1. Okay, now let's divide the results, because they have asked in terms of tan theta, no? So I am dividing second by first. So what will you have? 2m minus 1 the whole square minus 1 by 2m plus 1 the whole square minus 1. Write the expansion for this. So it will be 4m square plus 1 minus 4m minus 1. Here it is 4m square plus 1 plus 4m minus 1. Okay, 1 get cancelled. So numerator you take 4m outside, it will be m minus 1. In the denominator also you take 4m outside, it will be m plus 1. So 4m get cancelled. I am getting tan theta equal to m minus 1 by m plus 1, which is the required result. Okay, next problem. The resultant of two forces P and Q is R. If one of the forces is reversed in direction, the resultant is R dash. We want to prove this result. So see, first let me write R. So when they are acting at angle alpha, let us take they are acting at an angle alpha. So what will be the case? R square equal to P square plus Q square plus 2PQ cos alpha. See, when one of the forces is reversed, let me reverse this P. See, this is my first case. Okay, if my direction of P is reversed, see this is alpha, means this will be what? 180 minus alpha. Let me come to the second case here. So this Q will be the same, no change in Q, only P is getting reversed. So what is the angle between the forces? 180 minus alpha. So in that case the resultant is R dash. So R dash square is equal to P square plus Q square plus 2PQ into cos of 180 minus alpha. Understand? So when the angle is reversed, when the direction is reversed, the angle will get changed to 180 minus alpha. Okay, so R dash square equal to P square plus Q square. Cos of 180 minus alpha is what? Minus cos alpha. So this is minus 2PQ into cos alpha. Now you add this R square and R dash square. So P square plus Q square 2 times appearing. This 2PQ cos alpha get cancelled. So this is the resultant. Okay. Right. Next problem. Two forces acting at a point are such that if the direction of the one is reversed, the direction of the resultant is turned through a right angle. This is similar to the previous problem. So what they are saying is, see, initially when the forces are acting at angle alpha, we have one resultant, no, that is R. When the direction is reversed, we are getting another resultant is, that is R dash. They are saying the angle between this R and R dash is 90 degree for this particular problem. Okay, what we have to prove, the forces must be equal in magnitude. Okay, so I have drawn a separate diagram for this. So this is the case when the forces are, first case, acting at some angle alpha, when the direction of one is reversed, what they have given, this is the new R dash, no, here it is your old resultant R. The angle between this R and R dash is given to be what, 90 degree. Okay, so I'm going to make use of this one. See, tan phi equal to q sin alpha by p plus q cos alpha. This is for the first case, right? Next one, for the second case. For the second case, tan of 90 minus phi. How you are getting this 90 minus phi? See, this is going to be the angle in the second case, no, this is the angle between the resultant and the first force. See, this total angle is 180 degree. This is phi and this is 90, means this will be what, 180 minus 90 minus phi. So it will be what will be the angle? 90 minus phi. So tan of 90 minus phi equal to q sin of, here in the place of alpha, what will you write for the second case? 180 minus alpha by p plus q cos of 180 minus alpha. Can you understand? That is, it is better you can refer this diagram. So when you write for the second one, what is the angle? Alpha is changed to 180 minus alpha, no? So q sin of 180 minus alpha by p plus q cos of 180 minus alpha. How did I get this 90 minus phi? Here this angle is phi. This angle is phi, no? This angle is same here. But here my angle becomes this one. The total angle is 180. So this angle will become what? 90 minus phi. Okay. So tan of 90 minus phi equal to q sin of 180 minus alpha is sin alpha. And cos of 180 minus alpha is minus cos alpha. So p minus q cos alpha. Okay. What is tan of 90 minus phi? Cot phi. So cot phi equal to q sin alpha by p minus q cos alpha. Okay. Right. Now cot phi can be written as what? 1 by tan phi equal to q sin alpha by p minus q cos alpha. So for your better understanding, I have drawn a figure here. So this is my R and this is my R dash, new resultant. R is making angle phi with the first force. And here this is 90 degree they have given, no. So what will be this angle? This will be 90 minus phi. Then only the total sum will be 180. Again, when the angle between the forces is alpha, angle between the resultant and p is phi. When the angle between the forces is 180 minus alpha, angle between resultant and p is 90 minus phi. This concept only I have used here. Okay, now let us simplify this one. So 1 by tan phi equal to what we have? Q sin alpha by p minus q cos alpha. Okay, right. So here this tan phi, instead of this tan phi, I am going to substitute this value, q sin alpha by p plus q cos alpha. So when you substitute, what you have? P plus q cos alpha by q sin alpha equal to q sin alpha by p minus q cos alpha. Now let's cross multiply. So this is like a plus b into a minus b, no? So it's a square minus b square equal to, here this is q square sin square alpha. So p square equal to q square into sin square alpha plus cos square alpha. So which will be 1. So p square equal to q square. That means p equal to plus or minus q. That means what? The magnitudes of the forces are equal. Right. Next problem. If three forces PQ are acting at the vertices ABC respectively of a triangle. So my forces are acting at the vertices of this triangle and each perpendicular to the opposite side. See, this force P is acting here, no? If you extend this force, it will be perpendicular to BC. And similarly here Q is acting, if you extend this, it will be perpendicular to AC. And R is acting here, if you extend this, it will be perpendicular to AB. What we have to prove? P by A equal to Q by B equal to R by C. This small ABC, see in mechanics, whenever you have this small ABC in any triangle, they represent the sides, length of the sides. That is small a means this is vertex A, no? This opposite side is of length small a. This is B, no? This opposite side is of length small b. If this is vertex C, the opposite side is of length C. So this is what we have to prove. Now, see, I am going to make use of Lamis theorem. Why do I make use of that theorem? Whenever you have three forces acting at a point in equilibrium, Lamis theorem you can apply. Okay. So what is the Lamis theorem? Each force is proportional to sine of the angle between the other two. So P is proportional to sine of angle between Q and R. Q is proportional to sine of angle between R and P, and R is proportional to sine of angle between R and P. Now see, what is sine of angle between Q and R? See, this is force Q and this is force R, no? Right? This angle BOC. So angle BOC, and then angle between R and P. Where is R? This is R and this is P. So this is angle AOC. Okay, and then R and P. This is my, sorry, R and P is AOC, and then here also I have written, this is between Q and P. Sorry, angle between Q and P. What is this angle? AOB, right? So I have rewritten. Now here perpendicular, no, perpendicular means what? Altitude. In case of altitudes, this angle BOC is there, no, it will be equal to 180 minus this angle. You look at this triangle, see, this is one triangle and this is one triangle we are having, no. This is the property of altitude, that is when they are at 90 degree. Okay, when they are at 90 degree, this angle equal to 180 minus this angle. That is angle BOC equal to 180 minus angle A. And similarly, this angle AOB is there, no? AOB equal to 180 minus angle C. And this angle AOC is there, no? AOC equal to 180 minus angle B. So this is from the properties of altitudes. Okay, so here in the place of BOC, AOC and AOB, I am going to rewrite these values. So I am getting this statement. Now what is sine of 180 minus theta? Sine theta. So P by sine A equal to Q by sine B equal to R by sine C. And also one more result I have, in any triangle, each side is proportional to sine of the opposite side. So A is proportional to sine A, B is proportional to sine B, and C is proportional to sine C. So instead of the sine A, sine B, sine C, what can I put? A, B, C, where this A, B, C are sides of the triangle. Okay, so we have derived the result. Okay, next problem. A string ABCD hangs from fixed points A and D carrying a weight of 12 kg at B. So ABCD is a string. At the point B, I am hanging on weight of how much weight? 12 kg. Okay, and a weight W at C. At C, I am hanging a weight. So this is my string ABCD. Since at B and C, I am hanging a weight, it is coming down. Okay, AB is inclined at 60 degree to the horizontal. See, this is my AB, no? This is the horizontal line. AD is horizontal. So this is making an angle 60 degree. And then BC to the horizontal. And BC is horizontal. See, this line BC is horizontal. That means AD and BC are parallel. And CD is inclined at 30 degree. So CD is, this is CD, no? This is inclined at angle 30 degree to the horizontal. What is the value of W? This I want to find out. See, whenever at this point I am hanging one weight, no? So this weight is one force. Because of this weight, a tension is created on both sides of the string, right? This side let it be T1 and this side let it be T2. Okay, and similarly I am hanging on weight W at the point C, no? So it will create tension along both sides of the string. Let this be T2 and this be T3. Why these two should be T2? Because see, this is in equilibrium they have given, no? The given system is in equilibrium. So for making it in equilibrium, the forces along, that is the tension along this part, this B will be pulling it towards this side, and here at C this will be pulling towards this side. For balancing, okay, for keeping it in equilibrium, the tension along this part must be equal and opposite. That is why, so the tension produced by this 12 kg along the string and the tension produced by W along this string must be equal and opposite. That is why we have put T2, T2 here. Okay, these two are different because they are different portions of the string, no? They need not be the same. So for keeping it in equilibrium, this must be. Now this is the horizontal line, and we know the weight usually act vertically downwards. So if you extend this weight to this side, it will make 90 degree, right? I am extending this for finding the angle. For that purpose only I am extending. Actually the weight is hanged here only, not here. Here only it is hanged. For finding the angle of the triangle, I am extending this. See, this is a right angle triangle, no? So if this is 60, this has to be 30. And similarly, if this is 30, this has to be 60. Now what I am going to do is, the system is in equilibrium. Now look at this point B. Three forces are acting here. One is weight 12 kg, another one is tension T1, another one is tension T2. So these three forces are acting at B, keeping it in equilibrium. So I can apply Lami's theorem. So what is the Lami's theorem? Each force is proportional to sine of the angle between the other two. So first force I am going to take it as 12. 12 is proportional to sine of the angle between what are the other two forces? T1 and T2. And second force is T2. T2 is proportional to sine of the angle between T1 and 12. Third one is T1 I have to write, but I don't want that term. This T1 and T3 I am not bothered. What should I know? I want to know what is the weight. So I am not going to write the third term. That is not necessary here. So no need to write. Similarly at C, three forces are there. One is W weight, another one is tension T2, another one is tension T3. So W is proportional to sine of angle between T2 and T3, and T2 is proportional to sine of angle between W and T3. Okay, now let's see what are the angles. Angle between T1 and T2. See, this is 30 no, and this is 90 degree. So what is the angle between T1 and T2? Sine of 90 plus 30 equal to 90 plus 30. T2 by angle between T1 and 12. This is T1 and this is 12. See, this is total. This is straight line. No, this line is straight line. So 180 degree. This is 30 means this will be what? 180 minus 30. So sine of 180 minus 30. Let me complete this portion first. So 12 by sine of 90 plus theta is cos theta. So 12 by cos 30 equal to T2 by sine of 180 minus theta is sin theta. So 12 by cos 30 equal to T2 by sin 30. So 12 by root 3 by 2 equal to T2 by 1 by 2. These two get cancelled. So what do I have? T2 equal to 12 by root 3. So I find the value of T2 from the first part. Let me come to the second part. So sine of angle between T2 and T3. This is T2 and this is T3. No, this is 90 degree. So this angle will be what? 90 plus 60 equal to T2 by sine of angle between W and T3. This is my W and this is my T3. This is a straight line. If this angle is 60, this will be what? 180 minus 60. So W by sine of 90 plus theta is cos theta, and then what? T2 by sine 60. Okay, so W by what? 1 by 2 equal to W by 1 by 2 equal to T2 by root 3 by 2. So what do I get finally? W equal to T2 by root 3, or simply W equal to, instead of T2 what can I substitute? 12 by root 3. If you substitute the values, so finally I am getting W as equal to 4 kgs. Okay, right. Then next problem. A string ACB has its extremities tied to two fixed points A and B in the same horizontal line. To a given point C in the string is knotted a given weight W. Find the tension of the string CA in the form WB by 4C delta C square plus A square minus B square, where delta is the area and ABC are sides of triangle. Now what is given? A string ACB. Okay, a string ACB is there, and then what we are doing? To a given point C, so it need not be the midpoint. To a given point C, we are hanging a weight W. Okay, we have to find the tension. See, this is the string AB is the string. At some point C, we are hanging a weight W. Okay, so that by hanging the weight, it will create tension on both sides of the string. The tension need not be same. So let me take it as T1 and T2. Okay, right. Then what is the given thing? Weight WCA in the form. Well, we have to find tension along CA. That is T1 we have to find. Okay, now see, this is the weight. Extend this so that I will get a triangle. No, so this is 90 degree. This is horizontal line, this is vertical line, so it will be what? 90 degree. This is a triangle. ABC is a triangle. No, this is angle A and this is angle B. So if this is angle A, this will be angle 90 minus A, and similarly if this is angle B, this will be 90 minus B. Okay, so after marking all these angles, let me come to Lami's theorem, because I have three forces acting at C which are keeping the given body in equilibrium. No, so what do I have? I can apply Lami's theorem. So W by sine of angle between T1 and T2 equal to T1 by sine of angle between W and T2. No need to write T2. They are asking you only to find the tension along CA. Right? Okay. So now W by, what is angle between T1 and T2? This angle, no. So what is the total angle? 180. That is the total angle. What is this angle? Total angle, angle C. So W by sine C equal to T1 by angle between W and T2. This is angle between W and T2, no. This total angle is 180 degree. Okay, this is 90 minus b means what? 180 minus 90 minus b, which will be equal to 90 plus b. So T1 by sine of 90 plus b. So what do I have? W by sine c equal to T1 by cos b. So by cross multiplying, what do I get? T1 equal to W cos B by sin C. But the answer they have given everything in terms of A, B, C, no. So for that I am going to make use of some results from trigonometry. For any triangle, cos A equal to B square plus C square minus A square by 2BC, and similarly cos B equal to A square plus C square minus B square by 2AC, and cos C equal to A square plus B square minus C square by 2AB, and sin A equal to 2 delta. This delta is nothing but area of the triangle by BC, and sin B equal to 2 delta by AC, and sin C equal to 2 delta by AB. So instead of this cos B and sin C, I am going to make use of these results. So what do I get? T1 equal to W into A square plus C square minus B square by 4C delta. Okay, right. Then next problem. Two beads of weights W and W dash can slide on a smooth circular wire in a vertical plane. I have a smooth circular wire. This is my smooth circular wire, and I have two beads which are tied by means of a string. Okay, they are connected by a light string which subtends an angle 2 beta at the center of the circle. So the string is subtending an angle 2 beta at the center of the circle. Right. When the beads are in equilibrium, okay, the beads are in equilibrium, right, on the upper half of the wire, prove that the inclination of the string to the horizontal. Okay, so let me take this dotted line as my horizontal. Let me take that angle as alpha. Okay, this angle only I have to find. Okay, right. So what are the given things? I have a circle with center at O, and I have a string AB. Okay, at both ends of the string I have tied two weights W and W dash. Okay, this string is making an angle alpha with the horizontal line. This dotted line is the horizontal line, and this string is making an angle 2 beta at the center of the circle. So we have to find out what is tan alpha, right? So whenever you are tying, we have tension, no? The tension will be along the string. So this weight is producing tension T along the string. Since the system is in equilibrium, the tension created by this weight is also T in the opposite direction. Okay, right. Then afterwards, see, apart from tension, normal reaction will also be there. In circle, in case of circle, whenever you have normal reaction, it will be along the radius vector drawn outwards. See, OA is radius, no? So because of this weight, the some normal reaction will be there, no? It will be along this radius. So this is my normal reaction R, and similarly here normal reaction R dash. So at A, capital A and B, we have three forces. Here weight W, normal reaction R, and tension T. Here weight W dash, normal reaction R dash, and tension T. Right? Now look at this triangle. Here this OB and OA are radius, no? So this is an equilateral triangle. If this angle is 2 beta, the remaining two angle must be of equal, no? So this must be 90 minus beta, and this must be 90 minus beta. Okay, and this angle I have taken as alpha, and this is the horizontal line, and this W will be vertical, no? So the total angle is 90. So if this is 90 minus beta and this is alpha, this will be what? Beta minus alpha, because the total angle is 90. From that I find out this angle as beta minus alpha. And similarly, look at this small triangle with made with the horizontal line and AB. Okay, this is small triangle, no? If this angle is alpha, this is 90 degree, no? So this will be 90 minus alpha. So this is 90 minus alpha, this is 90 minus beta. So what about this angle? Alpha plus beta, and this one will be 180 minus alpha plus beta. So why do I find all these angles? Because I am going to apply Lamis theorem at the points A and B. So what is Lamis theorem? Each force is proportional to sine of the angle between the other two. So W is proportional to sine of the angle between normal reaction R and T, and T is proportional to sine of the angle between R and W. First let me complete at A and then come to B. Okay, what is the angle between R and T? This is R and this is T, no? So what is the angle between R and T? It will be what? The total angle is 180, no? So 180 minus of 90 minus beta, right? And then equal to T by sine of angle between R and W. This is R and this is W. Here also it is like what? 180, no? So 180 minus of beta minus alpha. So W by cos beta equal to T by, sorry, here it is 180 minus 90 means what? 90. 90 plus beta. So it is what? Cos beta equal to T by sine of beta minus alpha. Right? So this is from W. For W dash. W dash by sine of angle between R dash and T. What is the angle between R dash and T? 180 minus 90 minus beta equal to T by sine of angle between R dash and W dash. 180 minus beta plus alpha. So this is cos beta and this is sine of beta plus alpha. So W by W dash, that is when you divide these two results, W by W dash equal to, okay, sine of alpha plus beta by sine of beta minus alpha. Right. So what do we have finally? W by W dash equal to sine of beta plus alpha by sine of beta minus alpha. Now you apply combinando dividendo rule. Okay, so W minus W dash by W plus W dash. Whichever is bigger, we have to subtract. Okay, that's why I put this different sign. So W minus W dash by W plus W dash equal to sine of beta plus alpha minus sine of beta minus alpha by sine of beta plus alpha plus sine of beta minus alpha. Okay, so it's equal to, you apply the formula for sine of A plus B minus sine of A minus B. So all the terms get cancelled. I am getting cos beta sine alpha by sine beta cos alpha, which is tan alpha by tan beta. So what do you get? Tan alpha equal to tan beta into W minus alpha by W minus W dash by W plus W dash. Okay, that's all. Next, last problem. 5 forces acting at a point are represented in magnitude and direction by the lines joining the vertices of a pentagon to the midpoints of their opposite sides. Show that they are in equilibrium. So I am drawing a pentagon. Where are the forces acting? From vertex to the midpoint of the opposite side. This P is the midpoint of DE. Join this AP. Along this I have a force. Okay, and similarly AP, another one is what? BQ, another one is CR. This is CR where R is the midpoint of BD. Okay, etc. So like that I have 5 different forces. What you have to prove? All the forces are in equilibrium. So see, I have given you one extended parallelogram law. No? In that one I have given one special case. When lambda and mu are equal, OA plus OB equal to 2OC. Isn't it? Where C is the midpoint of AB. In the same way, for single force I am representing here. Now you take the pentagon and you consider this AP alone. See, this P is the midpoint, no? So these two sides are equal. That means they are in the ratio 1:1. So what do I conclude here? AD plus AE equal to 2 times AP. Okay. From where do I get this result? From the extended parallelogram of forces. In that one, so under the special case, what do I have? OA plus OB equal to 2 times OC. Right? In that same way. In the same way, I can do it for all the vectors. For one vectors I have drawn here. For all other vectors you can do. For the second vector, what is the second vector? BQ. BQ can be written as Q is the midpoint of CE, no? So BC plus BE. BC plus BE equal to 2BQ. And similarly, for CR, where is CR? This is my CR. R is the midpoint of BD. So CB plus CD. Okay, CB plus CD equal to 2 times CR. And what is the next vector? DES. S is the midpoint of AC. That means DA plus DC. DA plus DC equal to 2DS. And similarly for the last vector, what is the last vector? ET. For ET, T is the midpoint of AB, no? So EA plus EB equal to 2ET. Okay, now you add all the 5 results. Now see, plus AD, no? This is plus DA. AD plus DA equal to 0. Because same magnitude, opposite directions, no? So 0. AE plus EA. BC plus CB. BE plus EB. CD plus DC. Already the CB get cancelled. So all the vectors on the left hand side will get cancelled. They will become 0. What do you have on the right side? 2 times AP plus BQ plus CR plus DS plus ET. So this is nothing but sum of all the forces. Sum of all the forces equal to 0 implies what? The forces are in equilibrium. Okay. So I have covered all the problems in parallelogram of forces, triangle of forces, Lam's theorem, and what? Some special case of parallelogram of forces. I hope you understand this video. Thank you.